In this video, I'm going to focus more on mathematical functions and how we can determine the domain based on mathematical properties. And actually, I just wanted to, there's one thing I forgot that was actually really important about this example of functions, which is one condition of functions, which is not, one thing that's not allowed in a mathematical function. And one thing that I mentioned is that, well, actually, I forgot to mention this too, is that we are allowed to have repeats in a mathematical function. So, you know, what we do, a function is a mathematical set of correspondence where every element of the input is mapped to one element of the output. We are allowed to reuse elements of the range based on the domain, right? So like in the World Series, you're allowed to have the same champion more than 1 year. And that's something that can happen. And that's totally fine. But what can't happen is, well, I mentioned this before, everything has to be defined. So there has to be a champion. If there's no champion, it's not in the domain. So say, for example, baseball just decided to skip a year like 2020, which they didn't skip, but you know, it was potential for that to happen. But let's say they would, then 2020 would just not be a legitimate part of the domain and you would just have to scratch it out. But another thing that's not allowed is one element of the domain is not allowed to correspond to more than one element of the range. So let's say I were to add an arrow from 2014, like let's say that in 2017, both the Astros and the Dodgers won. And I'm bad at writing with my mouse, so I'm not going to write any further. Well, that would no longer be a mathematical function. Now we would still call it a relation, because a relation just relates anything to any other amount of things. And a mathematical equation is called a relation because not every equation is a function, but all functions are equations. And that's something we will return back to in a couple of videos. But basically, that's something that's not allowed in a function. So, and in the real world, a lot of our relationships are functions because for every input, there is one answer, there's an output. We don't like to have multiple different answers. And multiple outcomes is not a possibility in a mathematical function. So anyways, in a mathematical function, it's often described by a formula or by an equation, where we use the f of x notation typically to describe this correspondence. So in a mathematical function, typically the variable x is used for the input or the domain value of the function, and f is used to describe the output. Now in a typical equation, we often write y is equal to 3x or something, where it's done in the same way, where x is typically the input or the independent variable, and y is the output or dependent variable. And it's done in a very similar way. And there's not a big difference between functions and equations, but we'll kind of get at the small difference as we go. But anyways, a mathematical function is a notation of dependence, which is a little bit different than a function. And the notation's a little bit confusing because usually in math, when you say you were to write 3 parentheses 4, that usually means 3 multiplied by 4, right? And the answer would be 12. But with function notation, it does not mean f multiplied by x. It stands for f of x. And all this is saying is that we have an input variable which is independent, meaning you can it can be whatever it is. Oftentimes it could be any number, and that's that. And then the notation indicates that f is evaluated at x. It depends on x, which is why it's called the dependent variable. And the value of the function at x is defined by the equation. So the meaning here is that f of x is equal to 2x plus 3, is that the function will take on all the values based on x, based on the formula where it's dependent on this equation, this algebraic expression. And if I wanted to figure out, well, what's the domain in the range, I could do that very easily by plugging in numbers. And another thing about mathematical functions is often we encounter a function, but we're not given any information about the domain and range. So a lot of the time, the domain could just be anything, but there are certain restrictions based on the mathematical entities within the formula. So an equation like this, where it says to find the value of f of x, take 2 times x and add 3 to that. In this equation, there's just basic arithmetic going on, 2 times a number plus 3. There's nothing crazy going on, and typically functions without anything odd have a domain of all real numbers. Or basically, that's another way of saying it can be anything. And there's a lot of different ways to write what I'm getting at here, but basically you could say the domain is infinity, or but one of the ways to do it is by using set notation or by using interval notation or whatever. So since x is the domain, you could also write it like this: x is a set, is an element of the reals, where just to review this notation, this little e is is the symbol for element, where this sort of notation would indicate that the variable x is an element of the set R, where R is just the set which defines any number. So basically, all real numbers could be a whole number 1, 5, could be a fraction, 1/3, could be negative, could be decimal, could be rational, irrational. Basically, any number which is real could be in the domain. And the reason why that's the domain is just because we don't really have any other information beyond that. So we're just sort of assuming that based on the function at hand. Now, if this was corresponding to a real problem, that might not be true anymore. The domain might just be 0 to 10 or whatever. There's a lot of different ways to write it. But if you're asked to find the domain of a function, usually that's what they're getting at, is what are the valid numbers in that formula based on all possibilities. And in this case, there's no restrictions. And another way we could write that is if you're using set builder notation, and in the homework you'll sometimes see it written like this, is basically instead of writing it the way I did here, we'll write it as a set, where we write it's a set of numbers, and in math the braces are used to denote a group of numbers. So like up here, when I wrote this domain, I used the set notation where each individual element of that set is separated by comma. But sometimes, like in this case, we couldn't list every single number there is. That would take forever. So we're not going to list it as 1, 2, 3, 4, 1/3, 0.7, -42. We're just going to write it as the set of numbers x. This line means such that x is an element of the reals. And sorry, I was a little sloppy there. That was supposed to be the scripted R, which indicates the specific set of real numbers. But basically, this is just a way of writing exactly what I did before, putting it in a set notation. Or another very common way is by using interval notation. And I wanted to review interval notation as well, because that's a very common way of writing sets, especially in calculus and in the online homework. And basically, the interval notation is a typeset way of describing a number line of the numbers within the set. So like a number line would just be, whoops, I don't know why that's there. A number line is a way of visualizing numbers, and a lot of times we can draw intervals on a number line to help us imagine what numbers are part of a set. So like on a number line, typically we start with 0, 1, 2, if you know what I'm talking about. Basically, in this particular function, if we're trying to graph the domain on a number line, we're trying to figure out, well, which values, basically this number line could be the x-axis, and we're trying to visualize, well, what numbers are allowed. And since there are everything's allowed, basically we would shade in the entire number line, indicating that the domain is complete. It's the full real number line, and shading it in indicates that that's part of it. And so this helps me visualize, well, 0 is within the domain, 1 is, 2, 3, 1/2, negatives, any all real numbers, right? And on the real number line, since it goes forever and there's no stopping it, we call the right infinity and the left infinity, negative infinity, because basically this is going to go on forever. Infinity is not a number, but it's an idea of, well, what's the biggest possible number? There is none. So when we write this notation in interval notation, we go from left to right on the interval, and we basically put within either parentheses or braces, bracket, where a bracket indicates inclusion, parenthesis indicates not included. And basically we start from left to right, where negative infinity, comma infinity means from here to here and everything in between, the complete interval. And we're using parentheses on here because technically you cannot include infinity in your number set. This video is getting a little bit long, so we'll in the next video we'll look at a couple more examples, and we'll do the same sort of thing where we try to find the domain of these other functions.